All right. Now, guys, since we talked about the hippocampal formation and we talked about the entorhinal cortex, we've received everything from all brain centers, and now we registered everything by our recorder in the hippocampal formation. Now we want to get out of that. We need to understand who's going to help me to come out of that. So from the hippocampus, you guys, you're going to take the information. Remember the alveus, okay, that was the axons taking all the things, information from the cell bodies, recording the information in the hippocampus. And then you start to have the fimbria, which is your border, and then you're gonna have your information taken all the way around the thalamus here. Guys, here is your thalamus, and this is the hippocampus. You're gonna take the information by the fornix, and you're gonna wrap around the thalamus. It's gonna take you from down to up. You wrap around. You're gonna form something called crus, right and left crus. It's when you have an extension that into some place. This is what we mean by crus in Latin. So right and left crura will form the body of your fornix, all right? And then you have the commissural fibers, because you need the right side of your body to be aware of what happens in the left and vice versa. So you have the body of fornix. And once you come down here, okay, you're gonna have something called columns, okay? So once you have the body coming here, guys, you're gonna find a guy. That guy is called anterior commissure. So the anterior commissure is sitting down here. That will make you guys to split your information into pre and post commissural fibers. The pre-commissural fibers, you guys, will take information to different brain regions. And the post-commissural fibers is what's gonna form the column of the fornix, and it's gonna take you all the way to the mammillary bodies. Mammillary bodies, guys, it's gonna be the connection between everything that you've processed and the hypothalamus. And from here, you need to take the information further to next brain regions and see what to do with that information that you registered, because you need to react, right? This is very nice picture that shows you the difference between the mammillary bodies, which is way smaller than the amygdala. It's not like how you can see it in this picture. The amygdala, I told you guys, it lies in front of and medial to the hippocampus, okay? And remember that the columns are the post-commissural fibers of your fornix, because the information also needs to be processed to pre-commissural fibers, okay? It's not only the columns that will help me to process the information, it's also the pre-commissural fibers that will take the information to the septal area and prefrontal cortex, and you need to, sorry about that, okay, process the information further. Okay, now let's try to add things together. As far as now, everyone knows what is hippocampus and what happens there. Everyone knows what is the mammillary bodies, and you guys know the thalamus, okay? The thalamus is here, and this is the thalamus. It's the relay station that needs to collect all the information you have, and it's gonna tell your body what to do. Remember, the thalamus is your relay station. It receives information and it sends information to where it needs to be processed. Now, the basic Papez circuitry, we need to combine now the people we talked about with the axons connecting them, and we need to form something that explains to us how we process memory. So from the cingulate gyrus, you guys, from the cingulate gyrus, the blue one here, by the cingulum, okay, the cingulum is the fibers that will connect you to the hippocampus. You need to take information from the cortex, not only from the cingulate, it's also from the entorhinal cortex. Remember, we talked about that previously. From the cingulate gyrus, okay, you need to take, from the entorhinal cortex, you need to take the information to your recorder, okay? You experienced something, you need to take it to the recorder, you need to record it. Everything happens inside, we know about the internal circuitry, and now we're gonna take it outside by the fornix, okay? What's gonna reach the mammillary body is basically the columns of the fornix, okay? It's the post-commissural fibers of the fornix. Once you reach the mammillary bodies, you guys, you're gonna take the information to the anterior thalamic nucleus. In Papez circuitry, in forming new memories, in processing information, what's gonna happen is you will process this to the anterior nucleus of thalamus, not anywhere. And you will also have the dorsal median nucleus of thalamus, and that's gonna have a different function, and we're gonna talk about that as we proceed. Okay, so here we have the fornix taking the information to the mammillary bodies, and from here to the anterior nucleus of thalamus, and back to the cingulate gyrus. Okay, back to the cingulate, because you want to react. What is the name of the tract? We call it the mammillothalamic tract that will take you from the mammillary body to the anterior nucleus of thalamus. Okay, now here we are adding more information about the function of each one of the participants. The cingulate gyrus, like I told you guys previously, it's important for the behavior, sexual interactions and emotions. You need to have information, and then you need to react to that. The cingulate, and then like I told you, hippocampus is important in recording. All parts of hippocampus are important in recording. And then you take the fornix by postcommissural fibers, you reach the mammillary bodies, like I showed you in the fornix diagram. And mammillary body are important to in the recollective memory. And then from the mammillary bodies to the anterior nucleus of thalamus, I'm gonna show you guys those participants in brain, but here you need to understand the theory, and then you see how it looks like. From the mammillary bodies, you take it by the mammillothalamic tract. It's an easy tract because it's from the mammillary to the thalamus. Mammillothalamic tract, you process the information all the way back to the cingulate gyrus. By that, you've learned that thing, you've recorded that memory, and now you will start to react to what you've received. If you have a damage to any of those participants, you will have something called anterograde amnesia. It means you won't be able to form any new memory. What about the previous memories? It's fine. Nothing happens to the previous memories, because remember, guys, when I explained to you the parts of the cerebral cortex, the association areas, every area of our bodies that receive sensations, it has primary and secondary or association cortex. The primary is what makes you to sense, but the secondary or the association cortex is what makes you to register the memory. So after going through the recorder, you will go all the way to the association areas and register the memory that you've learned. So if you have any previous memory, it's already in the association cortex. So don't worry about that. So God forbids, if you have any region here, the problem is you're gonna use your recorder. You won't be able to record any new memory, whether it's auditory memory, visual memory, emotion, anything new. It's difficult to record. But if you have something that has been registered previously and stored in association cortices, it's fine. You know it, and you know how it feels. You know how to react to it. You understand it, and you know how to explain it. All right? Moving on, I want to show you guys on specimens how those guys look like. So remember, from the hippocampus down there, you had the entorhinal cortex. You have the hippocampus, so you receive the information from there, and then you process everything and you record it in the hippocampal formation, and then you take it all the way by the fornix. You have the crura of fornix, they unite together to form the body, and once you find the anterior commissure, guys, you are posterior to it. The postcommissural fibers are your columns. The column is gonna take you to the mammillary bodies. I'm going to show you also here. Mammillary body. All right, guys? What about the precommissural? That will take you to septal area and other stuff. Okay, these are also, the septal area is down here. Below the septum pellucidum is you have the septal area. Why is it important? Because I'm going to tell you in a while that septal area is important for rewarding center. Because once you register something, you need to react, and you need to register in its area. Septal area is responsible about the reward. So if you want to reward someone of something, I mean, like you've tried that, how achieving something good will make you take the first place in your class, let's say, and everyone is praising you, okay, so that area is going to be activated. And when you remember that, you will forever be working very hard, because it's registered in the reward center that this thing that feels good. It feels good to be different. It feels good to be a successful person. Okay? Now here, this is another good section that shows you guys how you take the information. Here, this is the frontal part. It's opposite. It's opposite to this picture. This is the frontal lobe. This is your occipital lobe's back. Sorry. And let's dig deeper. This is the corpus callosum, cut part. This is the cingulum. The cingulum are the fibers of the cingulate gyrus, and this is the parahippocampal gyrus. Okay, remember that was your limbic loop. Okay, guys, and deep here you have your hippocampus. Once you receive information by the hippocampus, you need to take the information back by the fornix all the way. You form the body of the fornix all the way. Okay, and once you find the anterior commissure, you will go back and form your columns. So the post-commissural fiber is going to be the columns of your fornix. That's going to take you to the mammillary bodies. From the mammillary bodies to the anterior nucleus of thalamus, it's going to be the mammillothalamic tract. All right, guys, so this is how it takes you all the way to the anterior nucleus of thalamus. And from there, you're going to go to the cingulate cortex back to know how to react to that stimulation. All right, guys? So this is how you can identify those structures in a specimen. Now, this is also another good specimen in a higher magnification that shows you guys the hippocampus, and then that takes you by the fornix, and then you form the body of the fornix. All right, so that was the crura of the fornix, right and left cross. And then you have the body of the fornix. And once you find the anterior commissure, you need to go back and make the post-commissural fibers. It's also what we call the columns of the fornix. That will take you to the mammillary body. The mammillary body, guys, it looks like a breast. Okay, so this is what we mean by mammillary bodies. So they are like two projections, nipple-like or breast-like, whatever you want to call it. All right, guys, it's basically those two nipple-like or breast-like projections down the hypothalamus. Thalamus is up there, and this is part of the hypothalamus. All right, so here, and then you take it by the mammillothalamic tract. This is G is the mammillothalamic tract that will take that to the anterior nucleus of thalamus for learning and processing the information, and that will take you back to the cingulate. Okay, so that you can react. Now we have more guys here. We have more people helping us, and they have the ability to do specific behavioral functions. The amygdala, you guys, it's responsible for fear and rage. So today we're gonna make amygdala as if he is our friend Amgad. Okay, so amygdala, he is we can call that Amgad is always angry, and he's always fearing stuff. Okay, so amygdala, remember, this is the fear center. If you activate it, you have more fear and rage and anger. It's negative emotions register in that guy. Septal nucleus and habenular nucleus, they are reward centers. They are for pleasure. So septal today is going to be another friend. She's going to be a lady, and we're going to call her Sila, I think. I gave her that name. All right, so Sila is going to be our positive girl. She's always having pleasure. Okay, why am I saying that? Because I want to help you guys to remember the name of the thing that connects them. Now, I don't want to talk about the connection now, because I have a nice mnemonic, or I have a nice way of helping you. So forget about this for a while. And let's see just those areas. So remember that the septal area was below the septum pellucidum. That was the septum pellucidum. Down here is your septal area. Remember, guys, when I talked about the fornix, I told you you will come to a point where you will have the anterior commissure. The post-commissural fiber will be the columns that will take you to the mammillary body, and then mammillothalamic tract and everything in the back to finish off the Papez circuitry. And I told you that there is pre-commissural. The pre-commissural will take the information to the septal area. Okay, so that was the septal area. In the back side here, we have the pineal gland back, and part of it is the habenular nucleus. And remember, habenular nucleus is important for reward learning and emotions and sleep-wake cycle. And now I want you to know what connects them. Let's go to the next and come back here. How will you remember the connection? Remember that something called the stria medullaris thalami. The stria medullaris thalami, guys, it's gonna connect septal area to the habenular nucleus. So we have sila and we have hiba. They are friends in the middle school. So they are friends in the middle school. What's gonna connect them is the stria medullaris thalami. This is the only connection that has the word medullaris. Stria medullaris. This is the thalamus, guys. That was the corpus callosum. Remember, this is the corpus callosum, and this is the cingulate gyrus up. Here is the septum pellucidum. Down here is the septal area. This is the thalamus. This is your core, the middle of everything. So if you have a connection that connects the habenular nucleus back there to the septal area anteriorly, this is going to be the stria medullaris thalami. Let's get back to that picture and see how we can see it in the practical examination. If you guys can see a white matter tract on the top of the thalamus that takes you from back to the front, this is gonna be the stria medullaris thalami. It basically connects the habenular nucleus back above the pineal gland. It's part of the pineal gland. It's gonna connect hiba to sila. Okay, this is in the middle school. All right, so they were connected in middle school. The stria medullaris thalami. And I want you guys to know one thing. Not everything we see outside means that this is everything. Meaning what? The stria medullaris thalami, this is only the part that I can catch. It doesn't mean it ends here. It's gonna end deeply when it reaches the septal area. And this is the best place we could dissect and show you guys for the stria medullaris thalami. Okay, so how will you remember it? It runs on the top of the thalamus. This is your thalamus, guys, and this is your hypothalamus. This is your hypothalamus, and this is your thalamus. If you see an axons, a white matter tract running top here, this is the stria medullaris thalami. All right, it runs related to the thalamus, so that's why we called it as such. These are all connections that you need to be aware of, because eventually everything you are experiencing and processing in your system, you need to react to it. You need to activate brain centers, because every center has a function, like we said. We have another tract, which is what we call the stria terminalis. So stria terminalis is a connection that connects important groups of gray matter related to the limbic system. Like we said previously, guys, amygdala, the fear center, septal area, it's the reward center, the hypothalamus, of course, because from there you get to proceed to different connections. And if your tract is connecting the amygdala to the septal area, or from the amygdala to the hypothalamus, we call it stria terminalis. How will we remember it? It's the terminal station. Amgad needs to reach to the terminal station in order to visit sila and hiba. But hiba now is not the habenular nucleus, it's the hypothalamus. All right, so how will you remember it? The terminal station, the stria terminalis, it's what connects that guy to these two ladies. So if you look at this diagram, it shows you how the amygdala brings the information from how the amygdala sends. All right. Oh my God. It's how the stria terminalis is connecting information from the amygdala deep down here, and it runs back and front all the way until you reach the septal area. Septal area is down below the septum pellucidum here, or the hypothalamus, which is kind of deep down here. All right. It's going to be a deep tract. So remember, not everything we can see from outside, it's not everything, all right? So this is only part of the tract that could be catch here in this specimen. However, the tract is way bigger than what you can see here, all right? So stria terminalis is the tract that connects the amygdala all the way to the septal area, or from the amygdala all the way to the hypothalamus. Now, we're gonna add up some information to tell you guys how we actually do. Now everyone understand the basic Papez circuitry. We understand how information are received all the way through the hippocampus to the mammillary bodies and then to the anterior nucleus of thalamus and then to the cingulate. And I told you guys that we have fornices that will take the hippocampus all the way, all right, by the fornix all the way to the mammillary bodies of the hypothalamus, right? The fornix is going to help you to take stuff out of the hippocampus. And also we have connections with the amygdala, and you guys don't need to memorize all the connections, but you need to know some of the connections and how do they connect those guys. Remember when Amgad wanted to reach Sila, it was by what? It was by the terminal station, right? The stria terminalis. So this is a connection. Now guys, the amygdala, it connects to the hypothalamus by stria terminalis as well. So Amgad can reach Sila and Hiba by the terminal station, stria terminalis. Okay, so remember that all those guys are going to get into the circuitry, and at the end you need to go to the prefrontal cortex, because here is your thoughts and ideas about everything that's happening. And also you need to go to all association cortices, because like I told you previously guys, if you are in the association cortex of, let's say, auditory, you need to register what you're learning so that next time you will know this is a good music sound. This is an information that I need to react to. So this is the place you're going to register the information. And that's why if you have a problem here, nothing here is going to change. Okay, the old memory is fine, but if you have a problem in association cortex, you're going to have what they call the retrograde amnesia. You're going to have something that has been registered previously and you cannot recall. Retrograde means it's something that happens before the accident or before the lesion. Anterograde, it means something that is happening after the lesion. And after the lesion should be with the recording system. Okay, in the hippocampus itself, in any of the people that will help you to register the memory. All right, now I want to link some things together for you guys. Remember that we've taken the basal ganglia, and those guys that are collection of gray matter inside the brain are always different things to remember, things to remember. Remember that in the core here, you guys have the thalamus. Remember when we took the caudate nucleus, it was turning around. It was coming from up to down, and it was lateral to the thalamus. And the fornix is the opposite. It brings information from the hippocampus down there, and it wraps around the thalamus from down to up and medially. By that, you guys know everything that happens deep in your brain. You know the thalamus. You know the caudate nucleus that wraps around, it's cut over here. And of course the lentiform nucleus was lateral. So you know that the caudate runs from anterior to posterior, up to down, and laterally. And the hippocampus connected with the fornix, and the fornix wraps around the thalamus down to up medially on the thalamus. And thalamus is always in the center, you guys, and everything is going to be related to it. Okay, so I just wanted to link those things together because that will complete the picture you have in your brain about those deep guys that we don't see them easily and it's difficult to recall. Now guys, in order to understand brain section, I found a very nice picture done by this website that shows you guys that it depends on the section you're gonna see what you're looking at. So don't, and for example, this is remember the nucleus accumbens? Okay, it's basically where the caudate nucleus meets the putamen. It's gonna be very frontal here. So I can have a cross section, a coronal section at that point, and you cannot see the nucleus accumbens. Why? Because you are very front, okay? You are in the frontal plane. Now, if you go back, you guys, you're gonna catch the hippocampus itself. If you are quite front to the hippocampus, you will be able to see the amygdala in the same place, in the temporal loop. So you guys need to know where you are. It's always fine to have a coronal section, but based on the section, you will find the structure you're looking at. Why am I introducing by this? Because I want to show you how to be able to see the hippocampus. If you guys see this looking, this is the hippocampus. This is your temporal loop. All right, guys, and the hippocampus is down here. That was your lateral fissure, because here we are at the back. I cannot see the nucleus accumbens. I'm at the back. But if you guys look at this area, this is not symmetrical. I can see the amygdala. And remember, guys, I told you amygdala is kind of in the front and medial to the hippocampus. So this is quite frontal than this. If you can see only the hippocampus, it means you are a little bit back to the amygdala. If you can see collection of gray matter deep in the temporal loop, this is going to be amygdala. If you can see this, you guys know how the hippocampus looks like. Everyone knows this is the hippocampus. It means this is only hippocampus. Okay? Why I introduced you previously to the idea of the sections? Because you can find something in the same place, but because you are in a different plane, you're seeing one different thing. And of course, we talked about all the other group matter nuclei. Remember that I told you guys the thalamus is always here. And here we are at the section where the mammillary body is there. So the mammillary body is here. Okay? And the white matter tract that connects the mammillary body to the anterior nucleus of thalamus, if you can see the anterior nucleus of thalamus, it's going to be called the mammillary-thalamic tract. All right? So thalamus is down here. Caudate was turning around it. All right, fornix was also turning around your thalamus. Remember when I told you guys about the linking things together? The caudate is wrapping around your thalamus. Fornix is wrapping around your thalamus. The difference between them is this is gray matter, but this is white matter axons. All right, so everything makes sense. All right, and this is your lateral ventricles. All right, and we already talked about the lentiform nucleus in the previous thingy. So here, this is also another one to show you the hippocampus, guys, down here, if you see this looking. And there might be also better looking images in the Google, but you guys know how it looks like, you know, the cornoammonis stuff and the things we talked about. All right. Okay, guys, so with that, we've reached the end of this video. Thank you guys for watching. I hope you grasped everything, and I hope everything is easy, and see you in the next topics.